Hi, Breanna. So I have on my screen right now some of the questions that I've assigned you, and I'm just going to flip back and forth between the questions in the textbook and this screen, which is just can show me trying some of those questions and try to kind of explain how to do things. I'm not going to show you the questions I've assigned, but you'll notice for a lot of them, I've given just suggested parts of the question. So I'll just do the ones that I haven't assigned you as examples. And then hopefully that'll help you do the ones that I am expecting you to finish. Okay, so let's start with question number 2, which says solve each equation in question 1. And I did assign all of these. So I'm just going to pick 2 that I think are a good representation. And and then you can try the other ones. Okay, so I'm going to start with number 2C, which is this one right here, k minus 4 equals 8. Okay, so number 2C, k minus 4 equals 8. Now, if you read through the textbook pages, you'll see there's lots of different ways that we can approach this. And one of those ways is to just kind of think through it logically. Like, okay, so k represents some number. And if I take 4 away from that number, the answer is 8. Okay? And maybe with a little bit of thinking through that, okay, so some number, take away 4 equals 8, will lead you to an answer that gives you k. Okay? In this case, I kind of know if I have 12 here and I take away 4, that'll give me 8. So that means k equals 12. Okay, and that strategy works for some of these questions, but it's not going to work for every question. So we want to try to figure out a way that we can solve them, even if we can't do the math in our head really easily. Okay, so that's what I'm going to show you here. And the idea we use is, it's called inverse operations. Don't worry too much about the words there. But the idea is that we're trying to get the letter, which we might also call the variable, by itself. Okay, and to do that, we have to get rid of the numbers that are on the same side of the equation as it. Okay, so this is an equation because it has an equal sign. I want to get an answer for k, which means I have to get rid of the numbers that are on the same side as k. In this case, that's the minus 4 right here. Okay, and I'm going to use the idea of inverse operations, meaning I'm going to flip whatever I'm doing. Okay, so I have minus 4 right here. The opposite of minus 4 is plus 4. So I'm going to rewrite this. I'm going to take the 4 away from this side of the equation, and I'm going to do the inverse of minus 4 on the other side. So then I end up with my answer, 8 plus 4 is 12. Okay? So that idea of inverse operations. And we have kind of 4 operations we're going to be dealing with. Addition and subtraction, which are inverses of each other. And then we have multiplication and division, which are inverses of each other. Okay, let's try one of the other questions from number 2. So if I look back here, let's try D. Okay, so 7u equals 21. So the way I read this as written right now is 7 times some number u equals 21. Okay, and you can try doing a check in your head, see if you can figure out the answer for u without having to write anything else down. It's called the guess and check method. Okay. But I want to go back to this idea of using inverse operations. So the 7 with the u right here, that means 7 times u. Okay? The inverse of times is divide. Okay? So to get the u by itself here, I have to do the inverse of 7 times on the other side. So I'm multiplying over here. That means on the other side, I would divide. Okay, and then 21 divided by 7. You're more than welcome to pull out a calculator to figure that out. I know in my head, though, that 21 divided by 7 is 3. So then my answer is u equals 3. Okay, Okay, so that's how you do number 2. Those are called one-step equations. So hopefully that example will help you. And then let's take a look at an example question from number 3 and see if anything changes. Okay, so question number 3 is actually kind of the same as question number 2. I know that it's asked differently. It uses this word linear, but don't worry too much about that word linear. These are just simple equations, once again, for us to solve. So let's look at, so I've asked you to do A, C, and E. So I'm going to leave those for you to do. I'm going to start with B, okay? So I'm going to show you how to do B. S plus 5 equals 11. So I'm going to go back here. Number 3, B, S plus 5 equals 11. That's kind of a tricky one because the S and the 5 look kind of the same. Okay, so I've got some number plus 5 equals 11. I'm adding, okay, which the inverse of adding is subtracting. So I'm going to keep my S where it is. And then I'm going to do the opposite or the inverse of plus 5 on the other side. That's minus 5. So then 11 minus 5, that's 6. Okay. I'll do one more example here from number 3. So in number 3, another type of question you have is dx over 11 equals 3. So we'll take a look at that. dx over 11 equals 3. Okay, and now this notation, over, it means divide. Okay, so this means x divided by 11 equals 3. And we can see here that the inverse of dividing is multiplying. So I'm going to take that 11 that I'm dividing by over here, and I'm going to multiply by 11 on the opposite side. So then my answer for that one is x equals 33. Okay, so that is 4 examples of how we might solve one-step equations, okay? Which means that we have a letter or a variable with one number alongside it, and we have to just use an inverse operation to get rid of that number, okay? So hopefully you can see that these were all obviously different questions, but there's kind of some similarities in how we think about them, okay? So I'm going to end this video here, one-step equations, and then I'll make another video to try to walk you through some of the questions as they get a bit harder.